Today we're going to talk about probability, specifically theoretical probability and experimental probability. And I'm sure you've heard of the term probability before and you've done some probability problems. So hopefully a lot of this will just be a refresher. So let's get at it. So Cooper rolled a six-sided die. What are the possible outcomes? So if I roll a six-sided dice, we could get a 1, 2, a 3, 4, 5, or 6. Now, the definition of an event is a list of possible outcomes. So the event rolling an odd number consists of the outcomes. Well, 1 is an odd number, 3 and 5. Those are the possible odd numbers we could get from rolling a six-sided dice. Now, the definition of probability is how likely an event will happen. And we've talked about it before where the weather, there's a 50% chance of rain or a 30% chance of rain. That's a probability that it will rain outside. So probability is a number from 0 to 1. 0 to 1. And it could be written as a percentage. You have a 30% chance of rain. It could be written as a fraction. You have a 1/3 chance of getting this answer right, or for guessing on the SAT, guessing a multiple choice answer, you have a 1/4 probability of getting the answer right, or a 25% chance of getting it right. And then the least likely one that we use is a decimal. We tend not to think about probabilities in decimals because it just isn't used in real life often. But as you can see from the chart down here, it's in a decimal. 0, 0.25, 0.5, 0.75 to 1. That's where your probability is. A probability of 1 means that the event will occur. And a probability of 0 is the event will not occur or not happen. When they say there's no chance of rain, that's the probability of 0. So how do we calculate the probability of an event? We use this formula right here, where the number on top is the number of outcomes, or I like to call this number of successes. Or number of what we want, divided by the total number of outcomes, or number, I also like to call it as number of possibilities. If we go back up here to our dice right here, we have 6 possibilities. But if I say, what's the probability that you roll a 5? Well, we want a 5. Rolling a 5 would be a success. And we have 6 possibilities. So the probability would be 1 out of 6, or 1 over 6. And then you could convert that to the the corresponding decimal or percentage. So I like to think about probability that way. So let's look at some examples down here that have to do with a deck of cards. And I have a tool that will help us with this. So you pick a card from a standard deck of 52 playing cards. Find the following probabilities. So finding the probability of picking an 8. And this part right here is just kind of an abbreviation, P for probability of picking an 8. So right here, we have all the cards, all the cards in a standard 52 card deck. So we have 4 8s right here. 1, 2, 3, 4. 4 8s out of 52. So this would be 4 out of 52. A success would be picking one of those 4 8s from the deck of cards, and we have 52 cards total. So you could leave the fraction like that, or you could also simplify it to 1 out of 13. Either way is okay, and they both have their uses. Not reducing it tells you that there are 4 8s out of 52 cards total, and the reduced fraction just tells you like it's a more meaningful fraction for us to work with. So letter B says probability of picking a red king. So probability of a red king. So let's go back to our sheet over here and see, okay, where are the red kings? We have 1, 2. So there are 2 out of 52 red kings, or 1 out of 26. It doesn't matter which one you use. All right, let's look at the next page. Probability of a face card or ace. So either one of those would be a success. I could pick an ace or a face card. Now, if you're unfamiliar with what a face card is, a face card is one of these at the end. Your jack, queen, king. Those are all face cards. So a success would be pulling any jack, queen, king, or ace. So let's see how many we have. We have these 4, and these 4, and these 4, and then the 4 aces. So we have a total of 16 successes. I could pick any one of these aces over here, or any one of these jacks, queens, or kings, and that would be a success. So the probability would be 16 out of 52. And if you wanted to simplify that, that would be 4 out of 13. Now, letter D, it says a probability of 7 or 8. So let's go back. Erase all this. And we want the probability of a 7 or 8. Well, there are 4 7s and there are 4 8s. So altogether there are 8 successes out of 52 cards. So 8 out of 52. Or if you wanted to reduce that, that would be 2 out of 13. 2 over 13. And the last one here says the probability of a red 7 or a black 5. So we only have 2 red 7s right here. And we only have 2 black 5s right here. Whoops. So we have a total of 4 successes, because getting a red 5 is not a success. I only want to draw a black 5 or a red 7. So there are 4 out of 52, 4 successes out of 52 total cards, or 1 out of 13. Now down here, we're going to use the probability for dice, but also apply it to see how many times an event should occur if we were to roll the dice 225 times. So if we think about rolling a 2, the probability of rolling a 2 is 1 out of 6, because there's 1 2 on the dice out of 6 numbers. So the way we figure out how many times we should roll a 2, we take the probability of rolling a 2 and multiplying it by the number of trials, or number of dice rolls. So maybe, so this was probability of rolling a 2 times the number of trials. And in the calculator, we would just do 1 divided by 6 times 225. So that's 37.5 times. So we would expect that, 37 to 38 times, and we can round up to 38. So about 38 times. Because you're right, you can't get 37 and a half times. You can't roll a 2 37 and a half times when you're rolling the dice. Now, letter B, a prime number. So, 1 is not a prime number, so 1's not going to count. So what are the prime numbers we have? We have 2, 3, and 5. 4 is not prime, and 6 is not prime. So 3 out of 6 times 225. So again, 3 out of 6 times 225. We get 112.5, or 113 times. And then letter C, a 3 or a 4. So rolling a 3 would be a success, and rolling a 4 would be a success. So we have 2 out of 6 times 225. So 2 out of 6 times 225, and that gives us 75. And again, these, until we would actually do an experiment, these are just estimations or theoretical probabilities. This is what we expect to happen, or what should happen, but it may not be what actually happens. Looking at the next section here, experimental probability, that is what we would actually see happen. So we just said, okay, based on these 225 rolls, we expect these results to happen. The 38 times, the 113 times, and the 75 times, based on the theoretical probability. And up here, you can say the same thing. Okay, your probability of pulling a 7 or 8 is 8 out of 52. But if we were to draw 52 cards, we may not get 8 successes. So the experimental probability is what actually happens. So what actually happens. So let's say we have this spinner here, and we'll say we have the color blue. I have a spinner up here, yellow, cyan, I think I saw red and purple. Yes, red and purple. So if I were to say, what's the probability of spinning a blue? So probability of blue, well, there's one piece shaded blue out of 5 possibilities. So we'd say, okay, the probability of getting blue would be 1 out of 5. Now let's spin this 5 times. And you can see this chart, this table here, is going to give us the experimental and theoretical probability. The theoretical probability is 20% for all of them because we have 5 sectors and they're all equal area. So see the first spin, yellow. So you can see right now the experimental probability is 100% because we only spun this once. So we're going to spin this 5 times and we should get 1 blue. Oh, there's a blue. There's another yellow, purple, and one more spin, purple. Okay, so we did 5 spins and we did have 1 blue show up. So this time our experimental and theoretical probability for blue were the same. And you can see that here in the table, 20% for both. But look at purple. The experimental probability for purple was 40%, while the theoretical was 20%. So that is the major difference between theoretical and experimental probability. So what actually happened in our demonstration? So what happened? The probability of blue was in fact 1 out of 5. But let's just say that the probability of purple, that was 2 out of 5. Whereas the theoretical probability of purple was 1 out of 5. So again, theoretical and experimental probability could be different. Now, if we were to make this, spin this, let's say 100 times, our experimental and theoretical probability should get close. So yeah, if it's going to keep spinning 100 times, and we'll check back on this after the next problem. So let's look at rolling a die. And let's say we wanted to get a 4. So the probability of a 4 would be 1 out of 6. So we're going to look at a dice simulation. And we're going to roll this dice 6 times and see how many 4s show up. Okay, so that was 1. That was 2. That was 3. That was 4. So far we've had 3 1s in a row. Okay, that was a 5th roll and a 6th roll. So it happened to be that the probability of a 4 was also 1 out of 6, what we would expect. But we did see that the probability of rolling a 1, we would expect it to be 1/6 as well, because there's 6 numbers and rolling a 1 is just one outcome. But when we did that experiment, it was actually 3 out of 6. So, that was kind of interesting to see. Let's check in on the spinner. Okay, so it's done 30 spins so far, and you see that the experimental probability, a couple of them are hovering around 20%, but cyan here is all the way down at 10%, and yellow is up to 36%. So if this kept going, we would eventually get to around 20% for each of them. So I hope that this was a good refresher on probability, and really the key idea here was, what's the difference between experimental and theoretical probability? That's what the main focus was for today, because like I said, I'm sure you guys have a good understanding of probability already. So thanks for watching. Make sure to like the video and subscribe.